Assalamu alaikum viewers. Today's lecture is about radio immuno assay. Radio immunoassay is a technique that is used to identify antigens in a sample. That means if you want to know that a particular antigen is present in a sample or not, you will do this technique, that is radio immunoassay or RIA. So what is the basic principle of RIA? The RIA involves the use of radioactivity to identify the presence of antigen in a given sample. So for that we need micro titer plate. This is the micro titer plate that is coated with the antibodies. It is pre-coated and available commercially with the antibodies that we will use here must be complementary to the antigen that we are identifying in the sample. So we need a sample in which we are identifying or we are locating for antigen. We need micro titer plate that contains the antibodies, and these antibodies are complementary for this antigen. And we need hot antigen also. What is hot antigen? Hot antigen is actually the same antigen that is present in the sample, but this antigen is coated with the radioactive material. For example, this is the antigen. Let's say it is GP14 antigen, and we are locating for the GP40 antigen in the sample. So for that we will prepare a GP40 antigen that is coated with the radioactive material like tritium or iodine 125. So when the antigen is coated with the radioactive material, it is called hot antigen, and the antigen that we are trying to locate in the sample is known as cold antigen. So actually what we are doing, we are trying to identify the presence of the antigen in a sample, if the antigen is present or not in the given sample. And for that, three basic things are required. Number one, the sample with the cold antigen, micro titer plate coated with the antibody, and a hot antigen. Hot antigen is exactly same as the cold antigen. The only difference is the radioactivity. This antigen is radioactive, and the antigen that is present in the sample is non-radioactive. So what is the procedure? We need the micro titer plate that is commercially ordered. It has pre-coated antibodies. So what happens to the micro titer plate? First of all, we add hot antigens. Hot antigens. Hot antigens, as we know, are coated with radioactive material. As this antigen is complementary to this antibody, these antigens will bind over available spaces or the available pockets of the antibodies. So now antibodies are fully occupied by the antigens, and there is no empty space for the antibody to bind further antigens. Also, some antigens will remain unbound in the sample. All of these are the hot antigens. So these hot antigens can also remain unbound. And to remove these unbound antigens, what we do washing here. Why the washing is done? The washing is done in order to remove all the unbound hot antigens from the plate. So now what we have the microtiter plate and the antibodies with only bound antigens, and antigens are hot antigens. In the next step, this is the step 1, step 2 is washing, and in the third step we will add actually I should use the same marker. Now we will add the sample over here, and we know that the sample contains the antigens which we are locating for, and these antigens are known as cold antigens. So these antigens are also compatible with these antibodies, and there is competition between the hot antigens which are already bound here and the cold antigens. But because the hot antigens have the radioactive material attached with them, so they are less compatible and less competitive than the cold antigen. So what will happen when the cold antigens or sample is added, the hot antigens will be removed and the cold antigens will start binding here. And now as a result, what will be released here? What will be released here? The hot antigens. Hot antigens are released. Why? Because the cold antigens have replaced them, because they were more competitive to bind with these antibodies, and as a result, because these are radioactive, and when they are released, there will be a process that is known as release of radioactive material or radioactivity. And this radioactivity will be proportional to the concentration of hot antigens released. That means the number of hot antigens released can be measured by the concentration of or the amount of radioactivity. So as we see that there is a release of hot antigen, that means same antigen was present in the sample. If there is no radioactivity, so we can say that if there is no radioactivity, that means there is no release of hot antigen, and that means there is no antigen in the sample. Which antigen? The cold antigen. The cold antigen. But when there is a radioactivity observed, that means hot antigens are released. Why the hot antigens are released? Because they are replaced by the cold antigen. And why they are replaced by the cold antigen? Because the cold antigen is present in the sample. So we can also quantify, this can also quantify the concentration of antigens in the sample. How? Because it is proportional to the radioactive concentration. And this is a very sensitive topic. Radioimmunoassay can analyze very small concentrations in the like in the nanograms of the antigens present in a sample. So actually radioimmunoassay uses the principle of the radioactivity to locate, to identify the presence of antigen in a given sample. It can be vitamin, hormone, drug, or in the serum. We can calculate the antigen present by the use of their respective antibodies on a microtiter plate, and by making the hot antigens that are actually the radioactively labeled antigens. And these radioactive or hot antigens, they are bound to the antibody on the microtiter plate, and when the cold antigens are added, these hot antigens are replaced by the cold antigens. And the concentration of radioactivity determines the concentration of antigens in a given sample. Thank you so much.